Singapore. I'm Aiman, and we begin with a developing story that could redefine our economy. Geologists have confirmed the discovery of a marine basin fossil site dating back 260 million years ago, right off our shores. Is this a golden ticket to economic prosperity, or a fast track to environmental disaster? To understand the stakes, we go live to our field reporter, Hugh, who's on site.
Thanks, Ivan. We're looking at the fundamental shift in our quality of life. Our team is balancing the dream of new jobs against the social penalty of industrial emissions. To keep our model realistic, we have laid out a few ground rules. The small open economy, we produce oil, but we don't set the global price. The domestic priority, we feel ourselves first to stabilize the local costs, and plug and play. We're assuming our world-class infrastructures is ready to go. Now, let's head to the data center to see how the math actually works.
The model is driven by two independent factors. First is the size of reserve, in the range of 50 million barrels to 600 million barrels, to keep it realistic in Singapore's context. Next is the purity index, 1 being the most pure and 0 being the least pure for the reserve. Now, these two independent variables will then drive the changes in our dependent variables. First is the cost of living, where we can see that if the reserve is more pure and is larger in scale, it will actually drive the cost of living down. Next is job creation. So let's say if it's a big size reserve, it will definitely create more jobs, indicated by the first factor here. The next one is the purity. So if it's requiring less refining or more, accordingly, it will also create jobs. And last but not least is the final factor here, which says that if the cost of living decreases, people will have more purchasing power, which will then affect job creation as well. And last but not least is social environmental impact. So essentially, how will refining and processing this reserve go? How much will it impact the environment? So as you can see, this factor here, 1 minus B, essentially means that if the reserve is more pure, it will have less impact on the environment due to the less effort it takes or less resources it takes to process the oil in the site. So these are our three factors, dependent variables. And now I'll pass it on to Nathan to explain how the equation works. Thank you.
Thank you, Aiman. So now, moving on to our quality of life. So for our new quality of life, we defined it in the following function, where you have our job creation divided by our cost of living minus our social environmental impact. And this whole value will be then divided by the cost of living baseline that we have today, so that we can get an average percentile value, knowing whether it is a positive percent or a negative percent that this marine basin will impact our economy. This can be simplified in the following, as can be seen by seeing the economic profit ratio minus the carbon debt over the quality of life baseline. This function is graphed above. And from this graph, we can conclude that for oil, should oil be closer to 0 for its purity index, we have a negative quality of life. But should our oil be closer to 1, we actually have much more gains for quality of life index. So this is what we can see from the graph. And for conclusions, let's bring it back to Aiman.
So the verdict? The fossil side is only a win if the oil is clean enough or our priorities are strategic. Our QLSG index gives us the tool to decide, do we drill for growth or protect our green future? For Team 8 News, I'm Aiman. This has been Modeling Space and System Special Report. Good night.